keep going on. The network defense, actually, we said that it is one of the main concerns and network security specialists that have to tackle. Mainly, it is a continuation to what we saw in chapter number 4. Yes, absolutely. But as a standalone scenario, you have to know the vulnerabilities and the issues to defend them as a security specialist. Network defense. What does mean network defense? You have to know the vulnerabilities. You have to have the necessary skills to exploit, searching for issues, weaknesses, and so on. So the first security approach to set up, since we are talking about the defense mainly, we're not talking tackling the issues. The first enhancement approach is the physical architecture. We started with the subnetting, absolutely, and moreover than the subnetting, there are technical and logical approaches we have to set up, via which we segregate the use of the network resources, the NATing and the NATing, pattern, subnetting, yes, and all the others. We'll see them one by one. Starting with the context of the NAT. Let's dig in first of all. Let's go on. The main insist that we have to stress on and we have to keep on mind usually is that the security starts with the design. Usually we have to start with the design, because when we eliminate entry points, we avoid issues. This is for sure. But whenever we have more than one, whenever we increase the entry points, we have to control all the flow more and more. So it's a more stressful work to do whenever we have more entry points. Thus, the physical architecture to segregate the access to resources physically, we talk about physically. We just eliminate this limit, this trunk from the network physically. So okay, we eliminated a list of issues, or a group of issues in this view. Thus, the design is the first. The design of the network is the first approach via which we set up the security. Okay. The context of the subnetting is a scenario via which we segregate physically and logically the computers forming a network, forming a computer network. Here we see two approaches via which we are going to set up a subnet or to implement the subnetting. Subnet means you are going to have a smaller network within a big network, subnetting to create the smaller network from within the big network. Classful addressing is the context of just segregating the addresses inside to generate groups logically. Classful addressing, via which you create subnets, but logically. So it's based on the use of the IP addresses. We are going to generate groups. We may have just one line interconnecting all the computers. One line, one direct line. We may use actually a bus topology. But logically, we are segregating or subdividing the computers into groups based on the use of the IP addresses. So we talk about classful addressing. The second, actually, still we are talking about absolutely we have to use different addresses still, but also not only stressing on the addresses only, but physically. We have rooms, we have groups, we have trunks, physically actually seen that they are eliminated. So physically they are subnet, they are generated as subnets. And then after we are going to award different IPs and different addresses, this is for sure. We take the example of our campus here, actually our building, our technical laboratory building, the building number 8. We have rooms, 8 number 1, 8 number 2, 8 number 3. They are physically segregated. This is an example of subnet. This is an example of physical segregation. And later on, not only are they actually segregated into groups. Don't touch the group now. ما وقت الجروب تو. Comes after the physical segregation comes the award of the IP addresses. Means absolutely we have to give them identifications. Roommate 1 has to be identified, roommate 2 has to be identified, roommate 3 has to be identified, but differently, in order to be able to see them as different groups, as different subnets. So physical and logical again. No escape from using the addresses as a tool to generate groups. Yeah, this is actually a graph here which we see different ranks, but whatever, we saw that. In order not to waste time, let's just pass through. The benefits and let's say positive side from using from setting up actually the subnets. We will be able to, for sure, actually, to gain network bandwidth. Means once actually the computers from within, for example, the 8.1 room are communicating in between themselves, they will not interfere the communications and the other parts from the network, from the computer, from the University of Nizwa main network, because they are locally communicating. So we are decreasing the network traffic from whether the network and the computer, the University of Nizwa network, by just giving them the chance to communicate locally. Number of computers from within one subnet is not final. What does it mean? It means actually roommate number 1 for room number 81, for example, it has for now 31 computers. Can we increase the number of computers? Yeah, absolutely. The answer is yes, true. Can we decrease, eliminate some computers? Also, the answer is true, yes. Flexibility, so it has to have this capability, and it has. So yes, it is good control, but it is not final. The number of computers from within a subnet, it's not final. Usually there is a chance for flexibility. And by generating a subnet, it is much more easier to troubleshoot, in the sense of, if the issue in the room number 81, it is much more easier to control the full room 81 than controlling the full campus network. Much more easier, because the full campus network, we have thousands of devices, but room number 81, for example, we have 31 computers. So much more easier to control 31 computers than when you control thousands, in plural, of computers. It's not the same. So improve troubleshooting, and it's much more easier to recognize what is the issue and where it is. More than that, in the improvement view, the IP assignment, the IP address assignment, it is not arbitrary. Actually, it is not just you have a new computer just to give him an IP address. No, there are secrets behind of that, actually technical approaches. Whenever you talk about the subnetting, the use of the IP address is much more ameliorated. We are not going to use what we don't need, and we will assign as much as we need only. We will not push the network devices, switches or routers or servers, domain servers, domain controllers, to have a long list of free IP addresses in the queue. No, they will only see the working IP addresses. Thus, there will be actually a time-consuming, time processing reduced. There will be an amelioration when we talk about the processing time. Thus, an improved utilization of the addresses. It is the reason. External routers. When we said that, for example, we want to make the room 81 devices to communicate between themselves, the switch in the building number 8 will not see that communication. It will not be influence. It will not have any impact. It will not be busy directing the communications from within the room 81 inside internally. No, only the switch inside the room will be taking care of that. So minimal impact on external routers. Clearly viewed, room 81, room 82, room 83, and so on, physically seen, and here we can classify them. Room 81 is subnet 1, room 82 is subnet 2, room 83 is subnet 3, and so on, physically seen. So the physical view, it reflects the subnet architecture or the subnet topology. Or what we presented as advantages, they are an enhancement to the network in question usually. Another approach via which we may enhance the security, or we build a defense layer on top of a computer network, is the virtualization, generating or creating a virtual LAN. Now, another topic. We have first key solution, which is the subnet, and now another second one, which is the virtual LAN creation, via which we are going to group devices all together to see each other, but virtually. They would be communicating between themselves, and none will see them also virtually. In this sense, what does it mean virtually? It means actually you are going to assign a direct path or communication circuit amongst those devices, but nobody will interfere unless he is authorized and he has the key to do so. So, can we use the internet to generate a virtual LAN? The answer is yes. Can you use a public network to generate a virtual LAN? Answer is yes, true. How it happens? It is just classifying them to be identified within the same group, logically usually, and they would be actually assigned a specific circuit and path to communicate through. They belong to the same group, they know the path of communication, and that's it. They would start communicating and sharing resources privately. The fact that they are virtual means they are private. Nobody will see them from the other members from the same network, from the network they are utilizing, unless they know the circuit and they know the key and they know they have the authorization to do so. Even sensitive data can be shared over a virtual network. Yes. A graph to demonstrate or to illustrate that. We have a building, for example, here, just one building made up of 3 floors. Each floor is having a variety of computers and devices. They are interconnected using a local switch. The other floor, the same thing. Devices interconnected using a local switch. The other floor, variety of devices interconnected using a local switch. That's all. And those floors, all of them, they are interconnected using a core switch. Here it is. This core switch is the external one. This is another one that has an interface to the external network, the external environment. This core switch is having in role and in consideration to interconnect those floors, those groups, let's say, and the work will start. Those devices, they can share resources amongst each other through this local switch, and they can share resources with the other floors using the core switch. Very easy. The concept is clear. To generate a virtual LAN, for example, to interconnect those devices, see this device and this device and this device and this device, to create an accounting, for example, department, the people responsible for finalizing the accounting activities, they are using this computer, this computer, this computer, and this computer. Physically, they are connected through local switches and core switch. They are having a path. They can share resources physically, but logically, we want them to be actually private, and they have to actually to accomplish their tasks and to share resources privately. How to happen? The virtual network is the solution. So they have to have a path via which the communication is encrypted. Nobody will see, nobody will interfere, only if he has an authentication to access the group they are using, those devices. So those devices, they are sharing the same. This computer, for example, this computer here, if he wants to send a message to this computer, he will use the same switch that this computer uses, but he will not see the messages sent by this computer because it's not in the same group, logically talking. Yeah, exactly what I was explaining. Another technology that we may implement to enhance the security, to build defense layer. Now a third scenario, a third approach, which is the convergence. The scenario, the convergence, via which we are going to specify that all the communications is going to happen through a choke point. We define that in chapter number 1, the choke point. Choke point, if you remember the security techniques, we define chapter number 1, the choke point means everybody has to pass through a dedicated point, otherwise they would not pass to the next level or to the next or to the external environment or vice versa. You want to use the internet, you have to pass through the server. You want to make a print, you have to pass through the server. You want to share a file or a resource, you have to pass through the server. So we are talking about a must pass through. These are convergence. Whatever the size of the network is, 2 computers or 100 computers or thousands of computers, all communications has to pass through a dedicated point. We are talking about a choke, C-H-O-U-K-E, choke point. We define that. You can refer to the chapter number 1 to see the security technique choke point. It is a convergence here. We will see the example clearly when we talk about the voice over IP communication. Why? Because not all networks they can have, they are having, not all computer networks they do have the capability to share voice medias. There have to be a media server, dedicated devices to support the voice communication. Actually, it is one of the tasks that the computer networks do. But specific devices, they have this capability. Thus, the convergence is a solution to provide this service, not only to provide the service. Here we are talking, remember, security-wise. We are not talking a solution to how to make this service run. No, we are talking security-wise. Because controlling a one path is much more easier than controlling 2 or n paths in plural. Because we are having only one line, so easy to control it. But if we're having a multitude of paths or circuits, the effort is doubled. It's much more big when we compare to a one circuit or one path. Thus, the convergence is a security enhancement. Due actually to this type of service, the voice over IP and the conversions, let's say maybe we may talk about the conversion, but not the conversion does not impose all of them, because when you talk about the lack of encryption, the conversion does not have to be happening without encryption. No, but the voice over IP has to happen without encryption. It is like that. Encryption, remember, it's a time to be consumed to encrypt and to decrypt, which is not accepted when we talk about live communication with 0 time latency. So this is a vulnerability, this is an issue. What is it? Communicating without encryption. Sound and media without encryption. This is seen only in specific services, mainly when they are live. You send now, you receive now. You share now, receiver receives now, and so on. Regardless, Those are issues related to the live communication, and mainly we are talking about the convergence and the voice over IP. Demilitarized zone is another scenario to enhance the security, to build another defense layer. Demilitarized zone, demilitarized zone. كل واحد يعودها. Repeat it in your heart, please. Try to read it. Demilitarized zone. It's not militarized. There is no military setup. What does mean military? We are not in an army. We are in a computer network or in computer security context. So means there will be no antiviruses, no firewall, no intrusion detections, nothing, no security appliances, completely demilitarized. There are services, mailing services, file server services, whatever, different services without security appliances. Do you believe that this type of network is considered to be a service in network? Yeah, absolutely. But service in what? Not the services that it mimics. The network, it has actually some services, and it is available on the perimeter of the real network. Let me just visualize it to you in a graph. We have a demilitarized zone, and we have the real network. Here are the services. Here the users, they are acting and they are using the services. But this one, it is for tracking and trapping intruders. Whomever is trying to hack this main network, there will be security here. But here, no security. So the attacker thinks that this is non-secured network and there are services. So he will try to hack. Immediately he will be caught. Anybody gets in here, he will be recognized who is it. And thereafter, he will be caught. He will be recognized, and the attack is failed because it is being diverted to this demilitarized zone. Demilitarized zones, there are two models. One with one firewall like what we see here, and one with two firewalls like what we see here. The difference is that in the one-based firewall demilitarized zone, admins can access directly to the network where the services are, the main network, without passing through the demilitarized zone. But for the model where the demilitarized zone is made up with two firewalls, everybody, even admins, they have to pass through the demilitarized zone, and then they get into the main network. Not only hackers. This is more tough, more severe. For whom? For the hackers, for the attackers, intruders. But it is more time consuming for the admins and the legitimate users. When we compare it with the one-based firewall demilitarized zone architecture, this is more slow. The services are more slow. He is more fast, but he is more secure. So there are advantages and disadvantages to choose this and that. Another defense layer, which is the NATing. Another defense layer, which is the NATing. The NAT. Very easy. Network address translation. We are going to translate the IP address, because the unique addressing we recognize so far is the IP addressing. We're going to give an alias to represent every device locally, and this alias is going to be shared externally. Simple. We're going to generate an alias, I repeat, and this alias is going to be shared with external resources, external environments, not resources, and thus the original and the legitimate and the main IP address is hidden from the external device, since the alias is going to be shared externally. Locally, the local IP address is hidden from the external environment. So if an attacker wants to attack computer number one, the computer number one is not recognized. Its IP address is not recognized. It's not viewed. So that is a network defense layer. Hidden identities. Hidden identities. Technique is the NATing. Just submit it to a graph. We have a legitimate computer. This is its own original IP address, but what the external environment, example, the internet, see the external environment see actually this IP address. She's not the same. This is the alias. So locally, who is going to generate this alias? Mainly we talk about a router or a dedicated switch or dedicated server. It will match the alias to the original IP address. The alias would be shared externally. The original IP address will be shared locally. That's it. Nothing is not the unique security defense in this layer of security, but also we may hide services communicated or communicating. How? What does it mean? Because using the same path, the same circuit, we may have many services communicating. What does it mean? Means using the same, for example, interconnection to the internet, we may upload files, we may download files, we may browse the content, the web service, the www environment. We may communicate upon voice, upon video. All of those, they are different services. How they are different? Because they are using different ports. Download port is not the same as whenever we're talking about the web surfing port. It's not the same. So the port means the service can be hidden internally and externally. The same thing. There will be an alias to represent the original port with an alias to represent the port externally. Port address translation. Here, the PAT, port address translation, does not have a job with the NAT. We do not have to make the NAT in order to make the PAT. No, completely different. No, we may have the same IP address for everybody. Not the same, but the original IP address for everybody, but different ports for every service. So the PAT is set up. Another, the same level, another security defense at the same layer, which is the control of access, network access control, the NAC, via which we generate actually an access control list. And this access control list technically will be utilized to authenticate the access to resources. Through the access list, the permission will be given to access resources or not. The network access control, actually this scenario of setting up the network access control is being set based on the use of two protocols mainly, not only, which are the DHCP protocol, domain host control or configuration protocol, and the ERP protocol. Let's pass to their definition immediately. Devices that can support those are brands and trends supporting those technologies. Okay, let me pass immediately to network appliances. Those are a list of third-party security appliances, security tools. We'll define them one by one. Actually, for the firewall, come back because I want to finish. Let me finish it here. For the firewall, it's a sort of a filter that actually is going to be based on some technologies to filter the flow in outflow. There are techniques via which those firewalls or those filters work. Mainly, they are going to see the packets packet by packet, whether they are allowed or not, because each packet, as per the definition of the NAT and the PAT, when we talk about the PAT specifically, ports are going to be altered, and the aliases, they are going to be altered packet by packet. So the firewalls, they have to have this capability to control the network packets, the flow based on packets. We have to recognize what does mean packet. It's not the unique technique, in order not to stress on that, because based on policies, firewalls or filters can work. What does it mean? Okay, any communication through mail servers is going to be forbidden, for example. So this is a policy. So not only packets-based filtering, but also politics-based filtering. And those filtering capabilities, they have to be done through either a software-based, means an application to install, or a hardware-based, it's a device to configure. Both of them, they are actually feasible, yeah. Firewalls, they have to be actually available in the perimeter of a network. It does not have to be inside the network. No, they have to be in the perimeter. As per the definition of what we said, here we are talking about policy-based filtering, stateless packet filtering, stateless packet filtering, means the rules or policies. We do not allow emails. We do not allow you to open the YouTube. We do not allow you something like that. So based on group of rules, the firewall will filter. Or based on the packets, packet by packet, the firewall will filter the flow. Just let me. This is a matter of reading only. The last point I'm going to stop at, which is the proxy server. Here we are talking still about filtering, but it's not a scenario of filtering to allow or not. But here we are making a camouflage. We are making a sort of hiding the original identity from being exposed to the external environment. It's something like the nothing, which is not nothing here. The purpose here is not to hide the identity only, but proxies will help to trespass, let's say, attack layers or attack interception layers or something like that. So any interception to be set on all communications coming from room 81 using a proxy will be actually vanished. Why? Because room 81 IDs will be hidden. This is the role of the proxy. We'll talk about the proxy and the reverse proxy just now in a graph. Let me just show it to you. Here it is. We have an original device with its original ID. The proxy server will make an alias, sort like an alias, which is a fake ID. Here we talk about IP address, to match the device internally. And this fake IP or fake ID will be shared externally. Thus, any interception, here security-wise we talk, we can interpret it differently, but for a security reason, this fake IP will not be the concern of any interception, since it is not belonging to the network in question. Thus, it would pass. Reverse engineering or reverse proxy, the same device who generated a match in between the original IP with the set alias, he will recognize the alias with the original IP whenever any external communication is coming in. Any questions, please? If you hear your name, please say yes.